Hi everybody, welcome to this video. Today we are learning how to model with linear equations. So our learning goals today are we're going to model a real life situation with a linear equation and then model a real life situation with a linear system. So a linear equation is just one equation, whereas a system is when we look at two different equations. So why do we use equations when we're talking about things in the real world? Well, this quote here says, the human mind has never invented a labor-solving machine equal to algebra. With algebra, we can solve problems efficiently and quickly rather than just using maybe guess and check methods. So many real life situations can be modeled using a linear equation. This means that we can represent an English sentence, something like 2 numbers add to 10, into a math sentence, x plus y equals 10, so x and y would be the two numbers, equals 10. So to find the solution to a situation modeled with linear equations, you will need two variables, so that's two unknowns, and then two equations using those two variables. So let's get started. So if all the equations are linear, which means the highest exponent is 1, there's not an x squared or an x to the power 3, we call this a linear system. So that's what we'll be dealing with this whole unit, is linear systems. So here's an example of a linear system. Here's our English sentence, and we're going to create two math sentences. So the sum of two numbers is 65. Their difference is 9. Find the two numbers. So in this case, identifying the variables seems a little bit silly, but we're doing it just to get into practice. So in this case, the unknowns are just the two numbers. So we can say let x represent the first number, and we can say let y represent the second number. Okay? And x and y are related, so find the two ways they are related. Well, the sum of the two numbers is 65. So sum means adding. So x plus y equals 65. Now, their difference is 9. There's a few different ways of writing this. I prefer to just write x minus y equals 9. So that's the difference between them, the subtraction between them equals 9. Sorry, I don't know why that disappeared. But there's a few other different ways that you can do it. So you can try maybe a few other ways of writing that second equation. So for example, you could have put y equals x minus 9, for example. So now you always want to do this, okay? You always want to test your equations. So what does this mean? Well, if two numbers add to 65, I just want to put them into my equation to make sure my equation works. So I know that, for instance, 60 and 5 would add to 65. So if I put in 60 and 5, that would add to 65. Two numbers that are 9 apart, for instance, are 19 and 10. So if I did 19 minus 10, I would get 9. Okay, so you're not finding the solution to both of these equations at the same time, because obviously that's what you're doing when you solve. You're just looking at them each separately to test, does my equation make sense? Does it actually do what it's supposed to do? Now, when we solve a linear system like this, what we're doing is finding the solution, which seems obvious, Mrs. Weens. But what is a solution? The solution is the numbers x and y that satisfy both of these equations. So they make both of these equations true. So the solution to a linear system is the ordered pair x, y that satisfies all the equation involved. So write this in your own words, something that makes sense to you. For example, you could put, it's the two numbers that make both equations true, or the two numbers where left side equals right side. But pause the video for a moment and just write what a solution is in your own words. So for example, the solution to this question above is 3728. That's because when x is 37 and y is 28, in both equations, you'll get left side equals right side. 37 plus 28 adds to 65, and the difference between the two numbers is 9. So that coordinate satisfies both equations. Here's a few more examples. Now, I know you're going to be eager to solve, but today we're not worrying about solving, just how to set up the linear system. Here's another example. The Leamington Flyers would like to rent a banquet hall for their awards dinner. They have received 2 quotes. The Roma Club charges $500 to rent the room and then $15 for each meal. However, the Portuguese Club charges, I'm trying to find my thing here. Here we go. $400 for the hall and $18 for each meal. So they want to know, when do both halls cost the same? And also when it would be a good idea to rent one or the other. So let's think about our 2 unknowns. Our first unknown would be how many meals there are. So we're going to say, let M for meals represent number of meals. So notice here that I didn't just put let M represent meals. Okay, that's not specific enough, because am I talking about the price of a meal, how many calories are in a meal? No, I'm talking specifically about the number of meals. So be as specific as possible. Our other thing that we don't know is the total cost. So we're going to say let C represent total cost in dollars, okay? So sometimes cost can be in cents, usually it's in dollars, but we should say the unit here that we want. Notice too that my independent variable is with a lowercase and my dependent variable is with an uppercase. That's pretty common in word problems. So then our 2 equations, so the Roma Club would have its cost is 500 plus 15M. And then the Portuguese Club would have 400 plus 18M. So now we have 2 equations with 2 variables. We would be able to solve that, and we will learn how next week. Let's do one more example. Your parents are looking for a new internet service. Leamington Wireless charges $30 a month, regardless of the use. Internet City charges $10 per month plus 25 cents per hour. So we're going to say, what are our 2 variables? Okay, so we're going to compare monthly costs here. So month is not going to be a variable. This is very important to understand, okay? We're just going to look at what 1 month would cost, because we're not controlling the number of costs, we're controlling the number of hours. So that's our variable. So we're going to say here, let H represent number of hours. And we're going to say let C represent monthly cost, be specific, in dollars. Okay, so first we have Leamington Wireless. Now their cost is $30 for the month, no matter how much. So in fact, this equation only has 30. That's fine. It's not dependent on the number of hours. Internet City, however, their cost is $10 plus 25 cents per hour. So those are the 2 equations, and you would compare those to find out which wireless service is least expensive for your, depending on how many hours you actually use the internet. All right, so that is modeling equations. So take a look at the success criteria. You should be able to identify variables using the proper language, create 2 equations with the same 2 variables, and then test your equations to make sure they're correct. So thanks for watching. I hope you learned lots.